In New Zealand, government healthcare is administered regionally via district health boards, which are shown in this map. The health boards run the free dental school service, which attends to about 90% of Kiwi kids. Decay data on 5-year-olds and school year 8s, which equates to 12 and 13-year-olds, is collected annually and published on the Health Department website. The spreadsheet lists the DHB regions on the left, and the data on numbers, percent, caries free, and DMFT are set out in blocks with the total, fluoridated, and non-fluoridated. And the data is also broken down by ethnicity, which I haven't shown here. Looking at the last 20 years, there hasn't been much change in the decay rates. This shows the non-fluoridated DMFT from 1990 to 2011, year 5-year-old and year 8, and this is the fluoridated. So it's been pretty constant. I'll be looking at more detail at the 2011 data. The 2012 data had a few problems and it was incomplete. The 2013 data was only released a couple of days ago. It shows no particular difference to what I'm going to be saying. When we compare data from fluoridated and non-fluoridated areas, we need to keep in mind a number of possible underlying factors. For me, the most important one is how long the teeth have been present in the mouth. This is something that's ignored by most comparative studies. The longer the teeth have been in the mouth, the more chance they've had to decay. We know that factors can affect this, such as different ethnic groups. For example, Maori and Pacific Islanders get their teeth up to a year earlier than Europeans. So we could expect them to have more decay at a particular age. There's also evidence that drinking fluoridated water makes teeth come through later in life, perhaps because of the melatonin effects that Ray was talking about earlier. In New Zealand, there are proportionally more Maori in the north and also rural living, which can affect decay data due to factors such as earlier eruption times, diet, socioeconomic status, and education. Furthermore, towns with higher Asian populations, such as Auckland, would trend lower, as Asians tend to have lower decay rates. With that in mind, let's look at the latest set of complete data, 2011. We see that the more fluoridated cities are in the North Island, and we see the more unfluoridated centres, Christchurch, Nelson Marlborough, are in the south. They certainly don't appear to be lagging behind. In fact, if you look at counties Manukau, with 5,500 fluoridated 5-year-olds, the decay incidence and severity is among the worst in the country, despite being fluoridated. And the DMFT data for 5-year-olds in urban centres show there is no obvious difference in the severity of tooth decay. Again, counties Manukau, fluoridated, is way out in front of the pack in the decay stakes. In the 12-year-old age group, again, there are no obvious differences, nor in the DMFT. To reduce possible regional variation factors, we can look at individual regions with comparable populations of fluoridated and non-fluoridated children. If we do this, we find, again, no particular pattern by fluoridation status, with some regions having more 5-year-olds with cavities in fluoridated areas and the other way around in other regions. In science, you need to ask serious questions if a result is the opposite to that predicted by a theory, and the theory does not hold in 50% of the cases. From this data, it is obvious that this theory is being constantly challenged. Einstein is reported as saying that if the facts don't match the theory, then change the facts. This is more difficult to do when looking at data from large communities. Again, there's no clear pattern in the 12-year-old figures. If we look at the intra-region DMFT figures for 12-year-olds, there's possibly a small advantage towards fluoridated areas, showing the 12-year-old DMFT figures, but this is probably a reflection, in my opinion, of delayed tooth emergence factors. in permanent teeth. So I just have to make sure that matches with this. Okay, so let's put it all together and look at the total New Zealand figures, the overall country. We see that the absolute difference in 5-year-olds between fluoridated and non-fluoridated areas is less than 1%. Clinically, you would need to look at 140 children in each group before you found an extra cavity in the non-fluoridated group. In 12 and 13-year-olds, the caries-free difference is around 3.5%. It means you would discover an extra decayed or filled tooth every 30 children. The severity of decay is indicated by the DMFT figures. Here we see a difference of 0.13 in a 5-year-old. Now, it's important to understand that DMFT is a cumulative measure. That is, it hasn't just happened overnight, it's taken 4 or 5 years to show this difference. By the age of 5, teeth have been in the mouth for up to 5 years. The yearly increment could therefore be calculated as 0.1 of the tooth. And in the year 8, the clinical significance of this difference is 1 extra tooth every 30 years. Now,